This is a different kind of substitution. It's still substitution. We're still going to take an expression and substitute it for a variable, right? So we're still going to do that. But we're going to use something called the transitive property of equality, okay? And basically what it says is that if A equals B and B equals C, then A equals C. So what does that mean? That means, right, if some number A is equal to B, and that same number B is also equal to this other number C, then these two numbers must be equal, right? Because they're both equal to this B. Okay, here's like an example in real life. If Bob and Joe are the same height, right? So Bob and Joe, they're the same height. So here's Bob. We'll call him B. And here's Joe. They're the same height. Okay. And Joe and Tom are also the same height. So look, here's Joe, and Tom is the same height as Joe. Right? What do we know about Bob and Tom's height? Well, look, we can see they're the same height, right? They're both the same height as Joe, therefore they're the same height as each other. So in systems, what we notice is that this is equal to y, and this is also equal to y. So hey, what does that mean? Well, if they're both equal to y, they must be equal to each other. So this is what the transitive property says. Okay. You can also view it as like, oh, I'm just taking this expression, which is equal to y, and substituting it in for this y, right? You could view it that way as well. Either way, when we have a system like this, right, what we can do is we can say, okay, well, if this is equal to y, and this is equal to y, then they must be equal to each other. And this, what I'm writing right now, is an equation with just one variable. And we know how to solve equations with just one variable. We just get all the variables together and we solve, right? So in this case, I have an equation that has x's on both sides. So I'm going to get all the x's to one side of the equation. In this case, I'm going to choose to subtract 3x from both sides. I could also choose to subtract 5x from both sides. Either way, I'll get the same answer. Whoops. But I'm going to choose to subtract 3x. And the reason I'm doing that is because I'll have some nice positive x's over here. 7 equals, right? Because if I had subtracted 5x from both sides, I would have ended up with negative 2x on the left, which is fine. But I like positives. Okay? I'm going to get x by itself by adding 1 to both sides. And I'm going to divide by 2. And I get 4 equals x. Okay, now, as always, for a system, I don't want to just have an x value, right? I need to have an x and a y value. So I'm not done. I'm going to plug this 4 back in order to find the y. Now, you could just plug it into one equation, but it's so quick that it just makes sense to plug it into both because it's like magically checking your answer as well. Right, so here, 3 times 4 is 12 plus 7, right? So y equals 19. Let's make sure we get 19 when we plug it in over here as well. I'm plugging in 4 for x, right? I'm plugging in 4 right here for x. And I get 20 minus 1, and hey, I get 19 again. Perfect. So my y equals 19 both times. So there's my answer, 4 and 19. And I don't have to check it because I kind of already did, right? Because I plugged it into both equations. Let's do one more. This is equal to y. This is also equal to y. They must be equal to each other. So I get negative 5x plus 6 equals x plus 24. Again, I just love to have x's positive, right? So I'm going to go ahead and add 5x to both sides. You could also subtract 1x from both sides. That would work. This is 1x plus 5x, that's 6x. And I'm going to subtract 24 from both sides because I'm trying to get x by itself. Okay, here x is being multiplied by 6, so I'm dividing by 6. And I get that x is negative 3, so I'm going to go ahead and start my little answer over here. Now, what's my y value? Well, let's see. I'm going to plug in negative 3 right here. Negative times negative is positive, so that's positive 15. And I get 15 plus 6 is 21. And I also can plug it in down here. Get negative 3 plus 24. That's the same as 24 minus 3. And that's also 21. So I feel pretty good about that. I get positive 21. And you can go ahead and use this workspace below to work on. The next 4 practice problems are going to be just like this. And these practice problems might be like this, or it might be like your notes on page 8. You have to decide which situation it is and which notes that you're going to reference.